So as I said, the two topics then is one is related to cyber-physical systems and industries 4.0 and smart factory, and the other is cloud manufacturing. So sort of have half and half. Just the first topic, or first set of topics. I'll just talk about the CPS briefly. It's probably not new to many of you at all. And Industry 4.0, smart factory concept, industrial internet, which is sort of American sort of way of thinking about Industry 4.0. So to start off, maybe some preamble, sort of background information about why we're coming to a time that we need to think about these different topics, and we need to spend time and effort on this. Well, the first thing is globalization and decentralization. These days, you don't make things in one place. You actually have people helping you out from different parts of the world. And the production systems are decentralized in many ways. And also we have a data explosion in a way that you can get data easily from almost anywhere. And so it's a good thing that you have data, but it's not so good if you don't know how to deal with it and how do you manage and how to analyze it. So that's why data in many cases doesn't equate to information. So you really have to analyze it and process the data so that it becomes useful information. So that means the data analytics is also important in this sense. And this connectedness and industry of things is also coming our way. I think it's been talked about in different contexts, the way that the things are connected, but also the people and the systems are connected, and these are also important. And then if you look at the production system, I think we used to talk about value chain, when it comes to production systems. I think now we're looking at not just a chain system, but it's actually a network. It's a value network. Things are connected in a more complex fashion, not sort of in a linear fashion. This happens first, and then you go to next part, next phase. So network is a key word here, I think. We just have to perhaps refocus a little bit. Now, cyber-physical system, I have to be brief on this, and there's probably a lot of expert here. But what is it? Well, this is perhaps my understanding, if you like. It's about sort of combining the virtual world with the physical world. Obviously, that's how the terminology came about. It has a focus on connectedness and also with intelligence. So it's no good just connect things together. You hope it works, but you really have to introduce intelligence and in the whole system. Well, when you communicate between different systems, between different machines, here, M2M communication, we have got that in the past. We may say it's not new. Well, it is true and it's not true. But what is new here is we're actually talking about semantic communication. So we're talking about things can communicate in a meaningful way, and people, and systems can understand semantics, not just syntax. So I think that's the key thing there we're looking at. Well, people are saying, well, cyber-physical system, is it not just embedded system? Well, I think it is technical term, it is embedded system. But people try to focus on closed embedded systems. Or embedded systems can be connected with other embedded systems. So it's perhaps a ecosystem for all the embedded systems, that they work cohesively and in a coordinated manner. And this will provide, a lot of functionalities once you have connected things together. When it comes to manufacturing, and people try to sort of have a manufacturing version of CPS, and this will be CPPS, Cyber Physical Production System. So this is perhaps more of our focus. But don't forget, cyber physical system can be anywhere, can in social worlds, can in any other walk of life. Then this Industry 4.0 came about. It's originated from Germany. That's why I keep the German spelling of industry there. I guess it's fitting there because it does come from Germany. Although when we were in Germany, all the presentations given by our German colleagues, they use proper English spelling there. Well, I think there's perhaps people talking more about factory level Industry 4.0 concept. What I think the way to understand this is that there are two aspects there. The one is really looking at the consumer, the customers, the users, and the other is looking at the factories that are making products. So really Industry 4.0 is about cyber-physical systems combined with perhaps Internet of Services, then give you smart products. So it is the product that becomes more intelligence, becomes smart. That's used by the customer. So that's on the product end, what you're making. And then on the other side, the factories that are making these components, these systems, these products, they want to be smart as well. And then the way to do that is to actually combine with the smart production processes. Then you have smart factories. So I think this is more talked about rather than these aspects. The smart factories can be very smart, but if you don't make smart products, it's no use. It's useless. So I think these two things come together. So I just got a few examples of this and a couple of examples of the other, the smart factories as well. So these are the two different contexts, don't forget. When we were in Stuttgart, we visited Daimler in Stuttgart, visit their factory, and this we had a talk given by Daimler talking about their vision. This is their concept car. They call it FO15. It was first introduced in early this year in Las Vegas. They call it luxury in motion. This is a typical example of smart products that company are making. Well, the few key aspects that are very interesting. One is really emphasize the interaction between passengers and the car itself. So this is in-car communication. So this is again bringing closer the passengers and the car they are in. And the other is interaction between the vehicle and the environment that's around the vehicle. So they had this extended sensor system. They try to get data from outside the car, around the car, and then to do some sort of processing and analysis. And they're also looking at connections between other vehicles. So vehicles talking to vehicles on the road. So that's another scenario, I think, if you like. So I think these are all indication of product and system being made to actually itself as a cyber-physical system, but it's also related to the concept of Industry 4.0. Just another slide about this car here. Some examples of interaction between vehicles and environments. For example, the car can interact with the pedestrian. They can have this whole array and matrix of LED displays and just to communicate with the pedestrian. And here they can project a zebra lines there so that pedestrian can travel, can cross the roads and safely, and can be seen by other people, other car users, other cars, other drivers. So this is really trying to communicate with the pedestrian outside the vehicle. And this is communication with the traffic behind the car, which can display different signs. Here, I don't know whether you can see this. This says slow, and this says stop. So it's not just an indicator, but it can. I don't know whether it can speak. But in this case, it's just to display some messages. Again, I would say it's just indication of how systems are being produced to be able to communicate with people and with other systems. So I think they all come under the same umbrella of cyber-physical system as Industry 4.0. Well, there's a lot of articles around this concept car. You can go online and have a look. So I think I won't go on talk about this aspect of smart products. I'll just focus on the other side, which is production systems and how we can actually use the technology to really build a smart factory based on CPS and other similar technologies. Well, there's no need to sort of go into details of this diagram. As anybody knows Industry 4.0 will understand this diagram. Well, what it says is really, this is coming out of Germany, of course, really looking at how industry has evolved through different stages, driven by different technologies at different time. And so this is driven by water and steam powered system. This is second stage revolution is driven by electrically powered systems, and then we have this IT-driven industry, and then this is industrial revolution based on CPS. I think this is IT-assisted periods, and this will be IT-driven or IT-centered industrial revolution. Well, you can debate about whether it's a 4 revolutions or 3 revolutions or even 5. Well, I think that's probably not the key thing here. But if you think about the progression, the 4 phases there as we've seen, and then when you look at our society now, you can probably understand why we are at this stage, at this point in time, that we need to think about cyber-physical systems. Well, really, digitalization of economic and social processes happened quite a few years ago. You know, this is what I consider first wave. It started since the 1980s. I mean, things like banking systems and consultings and publishings, you know, you can do things online for banking and for a long time. You don't have to go to the library to get a paper to read. You can just go online as a digital version. So I think this has happened already, but this is, remember, is really on the social process and economic side of this. And what we are seeing now is perhaps a second wave, which is really looking at physical systems being made addressable over the internet. So it is a natural progression, the way I see this. And it is a time that we actually look at the physical systems and how we can make it cyber ready and internet addressable, and so they can communicate with each other. So if you look at the whole landscape of digitalization of different things, it is the time that we are looking at these issues. Well, smart factory is actually what we really need in the end. So it doesn't matter what terminology, what technology you're using, cyber-physical systems, Industry 4.0, it doesn't really matter. What I need is a smart factory which can actually do things autonomously, for example, and it's perhaps not just the ICT-based control, but also the components, machines, and service robots, and these different elements of a production system can also communicate meaningfully and can act accordingly and autonomously. So it's actually another level further over this ICT-based control. And because you can sort of, it can have this autonomous acting sort of feature there, it will be easy to optimize the system for individualized products. So this is where we're going. And it's also easy to actually reconfigure your system and also easy to communicate with other resources outside your factory. You know, you might need to have some resources from a different country, and so this is why cloud manufacturing comes in here, really trying to bring resources on a global scale. And if you do this, you have very efficient resource utilization. And sustainable is another keyword here, and service-oriented practice. That's also important, because I think increasingly this is another sort of key words I want to emphasize. We increasingly moving into service-oriented system and products. And so I'll talk about this in a minute. Again, this is borrowed from a document from Germany. It's just illustrates the smart factory concept. I mean, as I talk about this, it's about smart machines which can communicate in an intelligent way. And then they form what we call cyber-physical production systems. And then factories, they are also interconnected. That's actually quite important. And so making sure this is not sort of isolated and self-enclosed system or factory. And these different smart factories can actually operate over a cloud network, and so that resources can be shared, and virtual enterprises can be formed. So that's, I think this is a good diagram to sort of segue from cyber-physical system to the cloud-based technology, if you like. Now, I mentioned about the American way of interpreting all of this, and very often they have a different focus and different view of what we are talking about. Well, they're not using the words cyber-physical system that much. They're not using the words Industry 4.0 that much in the US. But it's actually driven by some major businesses and major companies in the US. In this case, it's GE. They actually started looking at this issue quite a long time ago. So the term they're using is industrial internet. Well, in my view, it's same thing, Internet of Things, Internet of Industrial Things, cyber-physical systems. They have three focuses there when it comes to industrial internet. Is the machine that's being made intelligent. Well, that's not new. It's the same as the machines in the Industry 4.0. Advanced analytics, this is about processing data. That's not new either. People at work, and they really emphasize this aspect. I think it's important that I think it's quite fitting here that to really not to forget about the workers on the shop floor, the people who are using the system. So the three aspects they're looking at this. But in essence, I think it's the same concept as Industry 4.0. So we're not debating which one is one is correct. They don't have 4 industrial revolutions as the Germans have. They have 3 waves. Well, again, I won't go into the detail of this. It doesn't matter. It does not matter. What matters is at this stage where we are in now, how do we react? What do we need to work on? Okay, so they call it industrial internet. So machine-based analytics, physics-based and deep domain expertise and automated predictives and all these terminologies. I think it's basically Industry 4.0. Well, what's actually more interesting for me, this GE concept, is really this prediction from GE. They actually work with World Bank. This is very early on in 2011, looking at the potential GDP increase with implementation of industrial internet. So if you look at the global GDP, there's 70 trillion, around 17 trillion, and it's split into between developing economies and advanced economies. Then for each one of these, there's a non-industry economy sort of contribution, and then it's industry economy. So industry economy, non-industry economy. So we're interested in this industry economy, of course. That's where we are working in there. And that also has the quite a big share of this entire GDP map. But if you look at the industry economies, there's two sort of parts there. One is manufacturing contribution, and the other is others, the rest. And here, manufacturing and the rest. I can see manufacturing actually form the bulk of the GDP contribution. So I think that's very interesting in terms of the experts are predicting about the impact of the technology in manufacturing area. I think it can only be underestimated in my view. So that somehow tells me it is the area we need to focus on. The manufacturing is the area we need to focus on. So these are two big numbers there if you compare to the non-industry contributions there. I just want to sort of come back to highlight some of the key words. One of them is Industry of Things. This is really about connecting things together. And this data and data analytics and intelligence come out of your analysis of the data, and autonomy is also important. I talk about service. I'll come back to this in a minute. Very important concept. Very important concept. I think businesses realize this sometimes unknowingly. Smart products is the only way that we can sell well of whatever you're producing. The car we talk about, the Mercedes-Benz, the concept car, of course, is a good example. Smart factories, talking about autonomics of production, which means it's a very high level sort of intelligence.